Welcome back to the Explainer. Today we're tackling the absolute biggest headache in scaling AI applications right now, context bloat. Look, we've all been there, right? You build a general-purpose AI agent, you want it to handle dozens of specialized tasks, and suddenly the whole system just grinds to a halt. You end up managing this tangled, literal nightmare of prompts and routing logic that costs you hours of frustrating debugging. But there's a new standard emerging from industry leaders like Google and Anthropic that elegantly solves this. It's called agent skills, and it's completely reshaping how developers build reliable AI. Okay, let's dive into this counterintuitive reality. You naturally think that giving a large language model more instructions, more rules, and more context would make it smarter and more capable, right? Well, research is showing the exact opposite is true in production environments. When you stuff an agent with every possible instruction for every conceivable scenario, the AI doesn't get smarter. Actually, scratch that. It gets confused, it slows down, and its accuracy drops off an absolute cliff. We call this phenomenon context rot. Think of it like an overwhelmed human working memory. If I hand you a 300-page manual and ask you to hold every single rule in your head at once while answering a really simple question, you're going to freeze up. LLMs do the exact same thing. When they're fed massive system prompts filled with hundreds of conflicting instructions, they suffer from context rot and start just straight up ignoring critical commands. Here is the roadmap for this explainer. 1. The context rot crisis. 2. Anatomy of agent skills. 3. The evaluation toolkit. 4. Meta skills. And finally 5. A real-world retail case study. Section 1. The context rot crisis. If you've tried building autonomous, multi-agent orchestrations, you know the immense frustration developers feel when these systems fail. You either end up with one giant prompt that breaks, or a brittle multi-agent system where updating the invoice subagent accidentally breaks the HR subagent. And this brilliantly illustrates the massive token efficiency gained by switching architectures. Consider the old way, one big prompt. If an agent has 50 different workflows, stuffing all of them into the system prompt means loading upwards of 15,000 tokens on every single conversational turn. But with a skills library architecture, instead of one massive prompt, the agent has a library of 50 separate skills on disk. It only actively loads about 6,000 tokens, which is just the lightweight index of all skills, plus the specific body of the one skill it actually needs at that exact moment. The key takeaway from recent studies across 18 frontier models is that active context is a finite budget. It's not an infinite vessel. As the prompt size grows, models experience what researchers call the lost-in-the-middle effect. Information placed right in the middle of a massive prompt just gets ignored. Every token you place in front of a model takes attention away from every other token. A bigger context window just delays hitting the wall. It doesn't fix the underlying problem of context rot. Now, what's really interesting about this slide is the danger of getting this wrong. In a production analysis by Vercel, they found that an uninstructed, poorly designed skill doesn't just act as neutral background noise, it actively harms the system. An agent running without a specific skill scored a 63% baseline on a task. But when equipped with a poorly designed skill that lacked clear instructions, the agent's performance actually dropped to 58%. Bad skills actively subtract capability.
Section 2. Anatomy of agent skills.
So how do we physically build this missing architectural primitive? What does this actually look like on your hard drive? Let's demystify it. An agent skill is not some bloated new framework, and you don't need a complex vector database for it. It's beautifully simple. It's just a lightweight directory folder on your computer. Inside that folder is a single mandatory markdown file called skill.md. You can optionally throw in helper scripts, reference documents, or templates. It essentially gives an AI true on-demand procedural memory, teaching it how to do a specific task step by step. The magic of this folder structure lies in an elegant mechanism called progressive disclosure. It loads in 3 distinct layers to make sure the context window remains absolutely pristine. Step 1, only the skill's metadata, like its name and a short description, is always loaded into the agent's context. Step 2, the actual body of the sk.md file is only loaded when the agent decides to trigger that specific skill. And step 3, any bundled resources, like long reference manuals or Python scripts, are loaded strictly as needed. Because of this progressive disclosure, the markdown description is arguably the most critical element you're going to write. As the white paper emphasizes, the description field is your routing algorithm. It is literally the only thing the AI model sees when deciding whether or not to activate the skill. You've got to clearly state what it does, front-load specific trigger keywords, and, just as importantly, explicitly state what the skill is not for, so it doesn't misfire. Section 3. The Evaluation Toolkit. Building a skill is one thing, but trusting it in production is a whole different ballgame. We have to address the totally natural skepticism engineers have about deploying autonomous workflows. I really want you to internalize this hard truth straight from the source material. An agent skill without a test is a hope, not a capability. If you just write a markdown file and throw it into a folder without a testing framework, you're flying blind. We need a rigorous standard for production readiness. To get there, the industry relies on 5 complementary testing patterns. You have unit tests for every single code change, and golden data sets to catch execution and trigger failures in the draft phase. Then you step up to LLM as judge for read-only skills, red teaming to actively break things and test boundaries, and finally canaries or shadow testing to catch regression issues during a full rollout. Let's move to and see how this builds into a strict graduation ladder. Skills must pass through these explicit tiers before they're allowed to mutate any state. Things like sending an email or issuing a refund to a customer. They start as read-only, relying on LLM as judge evaluations. Then they move to draft-only, where they can propose actions but require a human to actually click approve. Only after surviving full adversarial red teaming do they graduate to action aloud, where they get to execute autonomously. Section 4. Meta skills and self-improvement. Once your foundation is solid, things get incredibly sci-fi. A meta skill is simply a skill whose job is to manage other skills, and they operate in 4 main ways. They can author draft skills from a human's brief description, but more impressively, an agent can watch a successful trajectory, like a human or another agent completing a complex workflow, harvest that trace, and propose a brand new skill folder to remember it for next time. They can also autonomously optimize existing descriptions and ultimately expand their own library as they encounter new problems. But here's the critical warning. Without ironclad evaluation gates, an autonomously improving agent will quietly make your library worse. If an agent is allowed to edit its own skills without strict unit tests, it's just going to start gaming the metrics. It might optimize a description to pass a specific test case while completely breaking a downstream workflow. Humans absolutely must remain in the loop, acting as the final gatekeeper for these auto-generated edits. Section 5. Real-world retail case study. Theory is great, but let's ground this in a concrete enterprise application to prove how elegantly this scales in production. Imagine a massive home improvement retailer. Instead of building one giant monolithic remodeling assistant, they partition their agent into specific skills owned by actual domain teams. The trades team owns the project guidance skill, detailing how to tile a shower. Pro merchandising owns the materials list skill. Fulfillment handles the delivery window skill, and customer service manages the return policy. Each folder is a distinct, testable unit of company knowledge. So the crucial point is, if that retailer tried to build a custom multi-agent system from scratch, they would face nightmare orchestration and tightly coupled code that just breaks constantly. By adopting a skills library format on top of a standard agent runtime, their intelligence shifts left. The architecture becomes modular, stateless, and easily versioned by the specific teams that actually understand the business logic. It avoids so many multi-agent headaches. Which leads us to this final, provocative thought to leave you with. Agent frameworks and foundational models are rapidly becoming commoditized. Everyone has access to the exact same baseline reasoning engines. So what actually sets your business apart? Ultimately, your true competitive advantage won't be the model you use, but the library of specialized, deeply evaluated agent skills you accumulate over time. Capturing your institutional knowledge into these lightweight, testable folders isn't just an IT upgrade. It's how you actually win in the era of AI. Thanks so much for joining this explainer, and we'll see you next time.